Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from integrals, right? So in this lecture we'll solve this important integral using the concept of beta gamma functions, right? So let us start and let us evaluate this integral from 1 to 3 x minus 1 raised to 7 x minus 3 raised to 3, right? And we'll see how we can use the concept of substitution method to reduce this integral into the gamma function, right? So let us first call this integral as I, right? So here I will make an important substitution, and let us substitute t is equal to x minus 1 over 2, right? So here this is an important substitution, right? Okay, now see here x varies from 1 to 3, right? So let us change the limits accordingly. So when x is 1, then the value of t can be obtained by taking x is equal to 1 in this expression. So we have 1 minus 1 over 2, that is 0, because 1 minus 1 is 0, right? And when x is 3, then we have t is equal to 3 minus 1 over 2. This is 2 over 2, that is 1, right? So when x goes from 1 to 3, then t goes from 0 to 1. So now we have t is equal to x minus 1 over 2, right? So we can write 2t is equal to x minus 1. So x can be written as 1 plus 2t, right? Now let us differentiate x with respect to t. So we have dx over dt is equal to the derivative of 1 is 0. So here we have simply 2 times 1, because the derivative of t with respect to t is 1, so we have 2, right? So now we can write dx is equal to 2 dt, right? Okay, so now we can rewrite this integral I in terms of t, right? So we have the limits from 0 to 1, because here t varies from 0 to 1, and for x minus 1 we can write 2t. So here we have 2t raised to 7, and here we have x minus 3. So x can be taken as 1 plus 2t, and here we have minus 3 raised to 3, and for dx we can write 2 dt. Okay, so now we can simplify this integral, and here we have 0 to 1, here we have 2 raised to 7. So distributing the power, here we have t raised to 7, then here we have 2t minus 1 minus 3 is 2, and here we have 3, and this is 2 raised to 1 dt, right? Okay, so we have 0 to 1, 2 raised to 7, t raised to 7, and here 2t minus 2. So when we take 2 common, then we have 2 raised to 3, and here we have t minus 1 raised to 3, and here we have 2 raised to 1 dt, right? So now we have 2 raised to 7, 7 plus 3 is 10, and 10 plus 1 is 11, right? So we can take 2 raised to 11 outside the integral. We have 0 to 1, t raised to 7, and here we have t minus 1 raised to 3, and here we have dt. So now we can write this integral I as 2 raised to 11, then we have 0 to 1, and t raised to 7, and here we have c, we have t minus 1, so we can write 1 minus t raised to 3, and we can take minus 1 raised to 3, and here we have dt, right? So what we have done here, we have written t minus 1 as 1 minus t raised to 3 and taking minus 1 common, because we want to convert this term or this integral into beta integral, right? So that's why we have here minus 1 raised to 3, because taking minus 1 common, right? So expressing t minus 1 as 1 minus t, right? So now we can write this negative 1 raised to 3 is minus 1. So we have minus 1 raised to 11. Then we have 0 to 1, t raised to 7, and 1 minus t raised to 3 dt. Right? So let us write this integral as 0 to 1. And here we have t raised to 7. 7 can be written as 8 minus 1, and here we have 1 minus t raised to 4 minus 1 dt, because writing 3 as 4 minus 1 and 7 as 8 minus 1. So now the Euler's integral of first kind can be expressed as beta mn, and we have 0 to 1 x raised to m minus 1 and 1 minus x raised to n minus 1 dx, right? So this is defined as the beta integral, and here we have the variable t in place of x. And if we compare this integral with this one, we have 0 to 1, then x raised to m minus 1, right? So comparing this integral with this one, the value of m is equal to 8 and the value of n is equal to 4, right? So now this integral I is minus 2 raised to 11, and this one is equal to beta mn, and m is 8 and n is 4, right? So now we have beta of 8 comma 4. So now this beta function can be expressed in terms of gamma function. So we have beta mn is equal to gamma of m, then we have gamma of n divided by gamma of m plus n, right? So we have I is equal to minus 2 raised to 11, we have gamma of 8, gamma of 4, and then we have gamma of 8 plus 4, that is 12, right? So to calculate the value of gamma 8, gamma 4 and gamma 12, we'll make use of this result, that is gamma of n plus 1 is equal to n factorial, right, where n is greater than 0, right? So gamma of 8 is gamma of 7 plus 1, that is equal to 7 factorial. Similarly, gamma of 4 is gamma of 3 plus 1, that is 3 factorial here. And then we have gamma of 12, that is equal to gamma of 11 plus 1, that is 11 factorial, right? So now we have here minus 2 raised to 11, and gamma of 8 is 7 factorial, gamma of 4 is 3 factorial divided by gamma of 12, which is 11 factorial, right? So now we have to calculate the value of this expression. So now see, here we have minus 2 raised to 11, 7 factorial, then 3 factorial is 3 times 2 times 1, that is simply 6, and 11 factorial can be written as 11 times 10 times 9 times 8 times 7 factorial, right? So this 7 factorial and this 7 factorial get cancelled, and here we have 2 3s are 6, here we have 2 4s are 8, and then we have 3 1s are 3, 3 3s are 9, right? So now see, we have minus 2 raised to 11 in the numerator, and here we have 11, then 10 can be written as 2 times 5, and here we have 3 times 4. 4 can be written as 2 square, right? So we have minus 2 raised to 11. Here we have 11 times 5 times 3. Here we have 2 raised to 1. 1 plus 2 is 3. So we can take 3 to the numerator. So we have here minus 3, right? So this is minus 2 raised to 8. And here we have 5 threes are 15. 15 times 11 is 165, right? So now the value of this integral I is equal to minus 2 raised to 8 is 256, and in the denominator we have 165, right? So viewers, the value of this integral is equal to minus 256 divided by 165, right? So this is how, by making use of the concept of beta gamma functions, we can evaluate these type of integrals.